Welcome to Pindar Poetry. We hope you learned something new.
You begin by confirming installed Quartus II and the exact device families you will target. This prevents synthesis mismatches. Once done, create a new project using your working directory, name it clearly, and add the top-level HDL immediately so tools recognize hierarchy. Make sure to import any existing IP cores or constraint files now rather than later. This initial commitment speeds compilation and avoids rework. By setting the device and project settings upfront, subsequent steps run predictably and faster. You now focus on implementing the design. Run analysis and elaboration to validate syntax and hierarchy so you catch errors early. Next, assign physical pins in the pin planner and create SDC timing constraints. Precise constraints guide the fitter and timing analyzer. Configure any IP blocks using the IP parameter GUI, then rerun analysis so the updated files are recognized. Once these steps are complete, the design is coherent and ready for compilation. Organizing files and constraints here reduces timing surprises later. You perform a full compilation which runs synthesis, fitter, and assembler. Examine the compilation report and timing summary to confirm timing closure. Once satisfied, connect your USB blaster or appropriate programmer, select the correct SOF or POF and program the device. Verify configuration LED indicators and tool success messages. If behavior differs, use Signal Tap Logic Analyzer for live captures and revisit timing reports to identify hold or setup violations. If stuck,
Thanks for watching. Consider subscribing if we helped you.